In this video, we're going to discuss the pentose phosphate pathway, which I like to think of as poking out from glycolysis. So as you can see on the left here, we've got glucose becoming glucose 6-phosphate. That's the first step of glycolysis. And some of this glucose 6-phosphate will continue through glycolysis and produce pyruvate at the end. However, some of it will also enter the pentose phosphate pathway, and that's what we're going to go through right now. So glucose 6-phosphate, first of all, becomes 6-phosphoglucodelta-lactone by the enzyme glucose 6-phosphate dehydrogenase, which I've abbreviated to G6P there. And in this process, an NADP becomes an NADPH. This reaction has some regulative elements that you should put to memory, because regulation is always important in metabolic pathways. So we've got insulin and NADP promoting the reaction to go forward, and glycogen and NADPH inhibiting the reaction. Because of course, if we had NADPH, which is one of our products in this reaction, then that means that we're not really going to need to produce it, because the cell has already sensed that there's enough NADPH being produced, so we'll inhibit it. And vice versa for the NADP. We have a lot of NADP, so we should convert it to the NADPH. So that's why the presence of that will cause the reaction to be promoted. So that's the regulation of the first step of the pentose phosphate pathway. In the second step, 6-phosphoglucodelta-lactone becomes 6-phosphogluconate by the enzyme glucolactonase. Picked up the wrong one there. And in this process, a H2O becomes a hydrogen ion. In the next step, we've got 6-phosphogluconate becoming ribulose 5-phosphate by the enzyme 6-phosphogluconate dehydrogenase. And in this process, an NADP becomes an NADPH, and a CO2 is also put out in this reaction. So that's the oxidative pentose phosphate pathway. There's more to it when you go to non-oxidative, such as ribulose 5-phosphate becoming ribose 5-phosphate by the enzyme pentose phosphate isomerase. And this can then become, so this ribose 5-phosphate produced by this reaction can then go into nucleotide biosynthesis. And there's more pathways in the pink arrows rather, that is going on. However, for my exam, I was told I just needed to know that the oxidative pathway, and that's probably the more important side of the pentose phosphate pathway. So get your whiteboard out and commit that one to memory. So let's talk about the products here. We've got this dark green outline around the NADPH here, and this is important because NADPH is used for a lot of important processes in the body. It's used for fatty acid synthesis, glutathione reduction, and other reactions such as detoxification. So let's go through what glutathione reduction is. So glutathione is a substance in the body, and here we have the chemical reaction that occurs in glutathione reduction. So in the body, reduced glutathione will become oxidized glutathione. Why, you may be asking? Well, it's so that we can convert hydrogen peroxide, H2O2, which is a reactive oxygen species and is dangerous to the body. It's so that we can convert this hydrogen peroxide to 2 water molecules, which are non-toxic, and we can maintain balance within the body. However, to do this, an NADPH must be converted to an NADP, and this NADPH comes from the pentose phosphate pathway. So that's the relevance of the pentose phosphate pathway, and that's why we mainly learn the oxidative pathway, because that's where that important NADPH is being produced for this important reaction where we removed the reactive oxygen species H2O2 from the body. And that's the basics of the pentose phosphate pathway and glutathione reduction.